So I'm going to talk about one use case among tens of existing use cases of CLIF in Orange. And it will be about service-oriented architecture. So what CLIF is about? CLIF is about testing a service performance and resilience to high traffic, what we can call also load testing. So imagine any system under test here, any application or equipment, and you want to test its performance. What you are going to do here for testing is that you are going to generate requests from those three blue boxes here, which are called load injector 1, 2, etc. Those load injectors will send requests, wait for replies, and measure the response times. And they will generate these requests according to a given scenario that defines the workload. And very typically, those scenarios will run what we call virtual users, which are the artificial representation of real users. It means that we want here to inject a realistic load, so it's most of the time modeled according to real user sessions through virtual users. And here you add also some resource probes that will make it possible to observe the computing and networking usage on the system under test. For example, CPU usage, network usage, memory usage, and so on. But you can also put it on the load injectors in order to check that they are not overloaded. Because if your load injectors are themselves overloaded, then you will get biased measures. So it's not a good situation. And possibly they won't run exactly the scenario that you have defined. So it's a good idea to check the health of your load injectors. And finally, you have the test supervision here, what we call most of the time the console, where you have the tester, benchmarker, and is supervising, so he can execute the test, monitor, control the execution of all the load injectors and probes, and finally generate a report. So what makes the difference between CLIF and other load testing tools? Well, CLIF comes with more than just the basic features that I've described before in the previous slide. CLIF really comes with advanced features. For example, you can change dynamically during test execution the number of virtual users. You have the support for tests of any scale. We have examples in Orange of tests with more than 10 million of virtual users, and also with more than 1,000 load injectors, which is a big thing. And we worked a lot recently during this year to optimize the deployment time and the resilience and the fault tolerance also, because when you get big distributed systems, you may have some faults, and well, you want to run your test, however. Also, what is interesting is that we have integrated the resource probes. So when you deploy a plan, there are both the load injectors and the probes. It's very convenient. And we have also, this is very recent, this is in a beta release now, an embedded reporting tool. What is also striking with CLIF is its versatility. First, it is independent from your operating system because it's based on Java 1.5. So you can run on Windows, Linux, Macintosh, Solaris, or whatever, or HP. It is integrated there is an integration to Eclipse, so you can use it as plugins or as a standalone Eclipse RCP application. There is also an integration to Hudson or Jenkins if you want to run a performance test in a continuous integration. There is also a command line which provides the full set of features. It's used through Ant or Maven. And you can define your own probes and load injectors very easily There is an Eclipse wizard to define your load injectors if you want to introduce your own protocol or API for generating a request. And you can also define your own probes if you have some specific equipment that you want to monitor. So the question is why Orange has launched this project and is still contributing to the project and leading the project. Well, the case of Orange is very particular. It's an integrated telecommunication operator, so it manages a vast variety of technologies, mobile networks, hotspots, fixed networks, all kinds of protocols for voice over IP or old voice technologies, or protocols dedicated to specific applications. A wide variety also of equipments, of service platforms, applications, and so on. So with more than 200 million clients in 42 countries, you can imagine that the performance issues are critical. Especially, Orange wants to provide, to be a reference in terms of quality of service and user experience, and also user confidence. So this shows that performance is really critical. Okay, so CLIF is led by Orange since the very beginning. It was launched with INRIA. And why do we? Why is this project strategic for Orange? First of all, for its versatility and its ability to be adapted to different technologies. And you have here a list of, I don't know how many protocols that we have been testing since the beginning. It includes very well-known protocols from the information technologies and networking. Things like which are related to the home boxes, and also some proprietary protocols for which, of course, no tooling was existing before we did it. Of course, it's much cheaper than specific commercial tools that Orange uses also in some cases, but which is not necessary for all these cases, or not adapted because protocols maybe are not supported. What is interesting in going open source is the feedback from the community, from the users, because what is very important for a testing tool is the confidence that you have in the results, in what you observe. And so getting feedback from a community will give you more confidence, because if there are some defaults in measures, then the community will tell you and you will be able to fix it. So it's very, very good for a testing tool. Also because the source code can be browsed by some advanced users that want to check that the measure is correct, for example. So feedback is very important. Of course, we have some community contributions, so we get more than what we have spent. And it's also interesting to say vector for research transfer. We did some research in software components with the fractal component model. Also in autonomy computing and now in cloud computing, and we have a lot of use cases of all of these advanced research topics that we applied in the field of performance testing. I will show you one of them. So now let's focus on the use case by itself, the WSOI. It means the Web Service Oriented Infrastructure, which is the Orange's web service oriented infrastructure, which is now deployed for many services. So before this infrastructure, each time we Orange or a partner was building a service. So the service is here, so it's either Orange or a partner, and the users are below. They are using this service. They use some enablers and services which are building blocks. For example, for sending SMS messages, an address book, storage capabilities, or identity management, login facilities, accounting, billing, and so on. You have all these enablers and services here. For example, you can manage the subscription to a service. And you have an infrastructure in the middle, in between, which will handle a lot of non-functional features like accounting, security, access control, service level management, or all this kind of stuff. And what happened is that we had a proliferation of specific infrastructures, you know, with so it's not easy to manage and to maintain. So came the WSOI platform with the idea of having a unified and shared infrastructure for web services. So the benefits are cost reduction, of course, because you have a common security, access control, scaling, supervision, and maintenance. Everything is just done once. And also, when a new project is starting, a new service is starting, there is no cost, no delay, because the infrastructure is ready. It's ready to use. And at the beginning, well, you have no cost to create it. But of course, the challenge is performance and availability, because you have a kind of central thing here. And of course, if it's broken, then many services, and including from third-party partners, will be down. So what about performance? There are currently 500 web services for the consumers and the providers, which are run on top, at the bottom of this bus, this infrastructure. And this is scheme. This line is the number of requests per month. Total amount of requests. So now it's 500 million calls per month. So how this infrastructure is built? If we focus now on this block infrastructure, well, first there is a load balancer. This is a hardware load balancer, and then after you have XML appliances, which means it is hardware that will analyze the XML flows. And then you have a configuration server, which will push some configuration settings with regard to one particular service. And you have also a directory to record, for example, well, a lot of things, but for example, access control, to know if which consumer and partner has subscribed to a given enabler or service. The main features of this bus, of this WSOI infrastructure, is XML validation, routing, because the block here doesn't know the address of the enabler of service. It is routed through the WSOI. Access control, service level management, security, encryption, compression also, because XML is very verbose, and also scalability. So the scalability is done here because you have this load balancer, very classical architecture, and you can put several XML appliances.